Hello, we're working on Chapter 7, Section 6, Adding, Subtracting Polynomials. I'm on page 487, which if you're looking at the PDF on Schoology, it's page 46. We're going to do problems 7, 8, 9, and 10. We're going to add polynomials together. And the way we're going to do this is by adding place value. Place value means the base to the same power. So I'm going to rewrite this. I got n to the third power, n to the first power with the hidden 1, and of course this is a constant, which would be n to the 0 power, but don't worry about that right now. I don't have n to the second power over here. I have n to the third power, and of course the constant. Over here I do not have n to the second power or even any n's. So I can use this one to start. I can do 5 n to the third plus 3n. And keep in mind that maybe I might need to put 0 into the second power if I had it over here, but I don't, so I'm okay. I just got to remember that it's actually there, I just don't see it. Plus 6. And then I'm going to put the 18 into the third power, lining it up with my other n to the third power. The 9 I'm going to put over here, and this big empty space here, that's actually 0 times n, like I was just talking about. I know that looks like I'm writing on, but it's 0, not an O. 15 plus 18 is 23. 3 plus 0 would be 3. And 6 plus 9 would be 15. For problem number 8, now we're using q as our variable. It does not matter. I've got q to the first power, q to the second power, q to the first power, and this is my constant, which again, like I said, is q to the 0 power. That q to the 0 power is going to be important. I'm setting you up for later. I've got q to the second power, q to the first power, and again, here's my constant. So everything's going to line up. 3.7, I'm not missing anything is what I'm trying to say. Q to the second power, subtract 8, q, and I always put the little tail on the q so it doesn't look like a 9, plus 3.7. Sometimes our letters that we use from our changes that we've made to our Greek letters and our Arabic numeral system, sometimes those look the same, like q's look like 9s and 2's look like z's if we're sloppy, so we kind of have to make it obvious. 4.3 q to the second power goes below the other q to the second power. Negative 2.9 q goes here, and my 1.6 goes here. Now, don't panic. You can do this. These numbers are not that bad. 7 plus 3 is 10. Carry the 1, just like that. 1 plus 3 plus 4 is 8. So I get 8.0 q to the second power. Both of these are negative. So negative 8.0 plus negative 2.9 is going to be negative 10.9 q. And 3.7 plus 1.6, think of it this way, 7 plus 6 is 13, put the 1 up there. 1 plus 3 plus 1 is 5, so I get 5.3. You can do that. Alright, now let's look at the next one before we start to write anything. I have negative 3x and 12. Those are not like terms. I've got 9x squared, 2x, and negative 18. So I'm going to line these two up, and I'm going to line these two up, but this one's not going to line up with anything. There's no other x squared. So I'm going to do something a little bit different, but it doesn't matter. Remember, if I said, what's 4 plus 3, that equals 7, that's the same as if I did 3 plus 4. That's an example of what we call the commutative property. The commutative property says it doesn't matter the order that you add things in if you've got 2 of them. The associative property says if you got more than 2, it doesn't matter the order that you add them in. Those are very closely related. So I'm just going to write this one first. And that's different than every other problem that I've done, but it's okay. Then I'm going to put the negative 3x underneath the 2x. I'm going to put the 12 under the negative 18. What goes under the 9x squared? 0x squared. Now, if you had written this on top, it would have been fine too. It's just that sometimes I see students make a mistake because then they think, okay, I have to line everything up, and they probably would have put this below that. So it was just think about what you do before you start to write it, which is always a good advice, especially if you're going to send an email or a text, right? Think about what you're going to do before you write it, and then plan it out first. It'll make it a lot easier. 9 plus 0 is 9, so I get 9x squared. 2 subtract 3 is -1, so I get -1x, or you can just say -x. And -18 plus 12 is -6. And I'm going to leave that just to bug people. All right. Same thing with this. I've got 9x to the fourth and 2x to the fourth. Those are going to be lined up. And I've got x to the third and x to the third. Those are going to be lined up. But look, what about what goes here? That's an x to the fourth. That's going to be lined up here, here, and here. Those are all going to, every x to the fourth is going to be lined up. Same thing with the x to the third power. So I got to write it like this. 9x to the fourth, that's that, plus 1x to the third, that's that. 2x to the fourth is going to go here. 6x to the third power is going to go here. -8x to the fourth power is going to go here. And one more x to the third power is going to go there. All right, now all my x to the fourth powers are lined up and x to the third powers are lined up. Good to go. 9 plus 2 is 11. 11 subtract 8 is 3. 3x to the fourth. 1 plus 6 plus 1. 7 plus 1 is 8. 8x to the third. All right, we'll see you in the next video.